Alright, so the video I'm going to do today has to do with the one that I uploaded the other day where I was talking about the RPG I was making, or, at least I was working on some RPG mechanics. I don't think I'm ever going to actually make a finished game, but I'm just I was playing around over Thanksgiving break, making some RPG mechanics, and one of the mechanics I think people were really interested in was the tiles sort of appearing as the player walked. Now, in this tutorial, or this video today, I'm going to sort of show you how I did that. Now, I'm not going to show you how I did the entire project today. I'm just going to show you how I did the tile animation. So there's some stuff I am going to skip over, but I think it's stuff that you should probably be able to figure out on your own, especially based on previous videos. Anyways, I'll tell you what that stuff is as we go along. And yeah, let's go. So the only other thing I want to say is that I don't know if this is the best way to do this. I'm not claiming that this is like really professional code or something, because I did throw it together in like a weekend essentially, but I'm going to show you the way I did it, and maybe you can get some ideas from that. And if you like it, maybe you know that there's a way that you can improve it. You can use it, whatever, or not. It's up to you. So the two classes we're going to be working in today, as you can see, I have my sort of RPG project here. It has a lot of classes, but the only classes we're working with today are the tile map and the tile class, because the tile is going to animate itself. It's not going to have any, I want to keep it as simple as possible, so it's not going to have any outside classes messing with it or anything like that. And I just have other than that, I just have a basic Libgdx project here. I hope anybody who's watching these videos has gone to Libgdx website, figured out how to set up a basic project where it gives you the desktop launcher and the, the starter little, starting class. I called this MechaCraft because I was originally going to do like some other ideas with it, so just ignore the name. The name's not important, but it gives you this like starter game class. And as usual, all I've done in the game class is made it extend game and then delegated to a game screen here. And the game screen, for the purposes of this tutorial, the only thing you need to know that it does is it calls the render method for the map, and it calls actually it doesn't call this because the map itself calls that, but it calls the render method for the map, and it calls the update and render methods for the player. That's all you need to know about the screen class today. And the desktop launcher is just like normal. I've set the width and height, and that's all I've done. So you don't need a whole lot to understand this video, because all these other classes that I was working with don't really have anything to do with what we're doing today. Just these classes. So anyways, let me show you what I've done already. So we have a tile map class here, and this is just like what I've done in previous videos. So if anything here looks foreign to you, maybe watch some of my other videos, because this is just like what I've done before. I've filled an array with sort of some base tiles, which are just, I'll show you actually. Where is the base grass tile? Which is just this base grass tile. That's what the array is filled with. And I'll show you the tile class in a moment. You can see that, this is the same math as before. Basically, we're going through a two-dimensional array, and we're determining the world position of each tile. Its map position is the row and column, right? So 0, 1, for instance, or 0, 0, or 2, 0, or whatever these might be. That's its position in the sort of map. And then X and Y is its world position. So the tile needs to know both its world position and its position in the map for various reasons. Actually, today, the only one that's important is the world position, but this is the math we use to get isometric world position. And maybe I'll talk about world position a little bit more in a moment. But anyways, you can see that all I've done is the same thing I did in my other videos. I loop sort of backwards through a two-dimensional array or whatever, and then I get world position from that and map position for each tile. I make a new tile, add it to the tiles, add it to the tile array of tiles, and then we just loop through it. And that's it. We just call each tile's render function. Very simple. This isn't changing at all. This doesn't need to do anything else with the tiles. Oh, I also entered the delta here because we're going to need this delta variable, as you've seen in the moment. I've talked about this delta variable before. It's essentially how you lock things in games based on time. It's like the time between frames, so that you can have like a, things happen at certain intervals, right? You can say like, okay, I'll show you in a moment. We're gonna do some of that. Anyways, cool. So this is a very simple class, and like I said, I've done this in other videos. All this init function does is initialize the variables I have up here, and I have a public static final int for my map size, which is going to be 32 tiles by 32 tiles. It could be any size though. You probably want it to be rather large though, for this particular example. And then my tile width is 64 pixels and my tile height is 32 pixels. That's what I've chosen for my tile width and height. And as you can see, those play into determining the world position of the tile, which I'll talk about in just a moment. And then all you do, I assume everybody's familiar with basic object-oriented programming, is you make a new tile and you add it to the tiles array so that you can call its render function. Cool. So in the tile class here, this is really, really simple. We have a world position, tile map position, map position, just like I was saying before, which is the row and the column. Then the X and Y is the world position, which we'll talk about in a moment. And then I'm just drawing it. So what do you get from this? You're going to see a bastardized version of the RPG I showed in the video the other day. So right now, as you can tell, because the map is not constrained on how much you can render at any one time, it just renders the whole thing. And my sort of UI here was not made for that. It was made for it to only render one part of it. Now, tile position is obviously like, for example, and you can see the player can move around in here. Tile position is, for example, if this is 0, 0, 0, 1, etc., that type of thing. World position is sort of its position from like the texture's position from, I believe, the bottom left corner. If not, it's the top left or something like that. But I can't remember how Libgdx does it exactly. But I believe it's about bottom left corner. But the point is that like it has this tile position of 0, 0, right? A tile map position. But then it also has a world position, a position in this like broader world that our game exists in. Now, this is not screen space. It's not the screen position, right? Because this could be screen position, whatever, 200 by 700 or 1000 by 1200 or whatever this is, but in the actual world. So you have to think a little bit abstractly here. Your world has an origin somewhere. And if you were to move the camera off into infinity this way or that way or any way, your world is infinitely big. But my point is like the tiles are going to start at the world's origin, which is obvious because if both of these are like 0, 0, then this ends up being 0, this ends up being 0, which means this entire equation ends up being 0. So your first tile will be put at world position 0, 0, and then it'll go up from there. And maybe that'll help you understand this math a little bit. Just take a good think about this. I think this is something that's when you sort of like start writing out some numbers and maybe print out some numbers or something and start thinking about this, you'll be able to visualize it a little bit better, when you think what the relation to tile map position is to its world position or whatever. So that's all we really need to get going. The only other thing I'll say is that the other requirement is that your player's position, sort of his, your player's like tile map position, and you have the ability to move your player. But honestly, Libgdx's input system is really easy to work with. So figuring out how to move a player is not that hard. Also, I've done it in previous videos. I've time locked the player a little bit so he moves at a certain speed, but that's not that hard either. You can just do it using the delta variable, but maybe I can make a video on that later. That's just not what the video today is about. But the point is you need to know your player's position in the tile map, and you need to have the ability to move the player, and also the camera has to move with the player. So if you'll notice, when I move, the camera moves with the player. So that's also a requirement for what I did here, but that's as easy as making sure that the camera's position is always relative to the player's position, right? So get the player nice and set in the wherever you want him in the camera, whether it be the middle or wherever, and then just always whatever the player moves, make the camera move the same, right? It's that simple. So that's all the requirements. Now, with that said, let's get started in the tile class. Right now, we're just drawing the tile. The tile we're just drawing its texture to its world position. There's really no mystery there. Now, first, I'm going to go ahead and get started. I'm going to say, well, oh, by the way, I guess I should say this. We're passing in Delta, the sprite batch for rendering. The sprite batch is how you render things in Libgdx. I think pretty much anyone who's used Libgdx at all probably understands what the sprite batch is. If you don't, I really suggest just looking at the documentation for this, because it's really not that complicated. Also, it's just not really the subject matter of this particular video. But anyways, in the Delta variable, you'd probably be better off Googling this too, rather than me explaining it to you. But it's like the time between frames, or it's like the, it's the way to get time in games. So if you have like a time variable and you're adding this to it every, frame, and once that time variable equals 1 second has passed. So you can say like, okay, well, if the time variable equals 1, do this code. So you can do that code every 1 second. It's just a useful way to do things at a time step or something, in a particular time step or whatever. This is the player's tile map position. That should be really obvious. That's just getting passed in because our, I moved it into the init function, but our tile map has a sort of reference to the player that it has a reference to the player in the class. And anyways, I've just set so it knows about the player, and it passes the player's tile map position on into this function. But like I said, we're not going into all that today. Just know that you have to be able, your tile has to know about your player's tile map position to do what I did. And anyways, here's why. Cool. So I think that now, why am I using math.absolute value here? Well, the first thing we're going to have to do is check if the tile is going to check if it's within range to be seen by the player. That's the first thing our tile is going to do. So I don't know why I capitalized map in that, but so if the tile map's X position, is within 4 units of these sort of, and we'll just give me a, there's probably a way I could do both of these at once or something. Like I said, this code isn't perfect. I'm just like, all right, I like to do a little, and then the Y. So if it's within 4 tiles of the player, and you can set this to be whatever arbitrary number you want. I just found that 4 worked for me. Okay. So if it's within 4 units of the player, we want it to draw, right? That's true. For sure, that's true. We want it to draw if it's within 4 units of the player. Now let's see. Okay, that by itself already gives us something, right? Like, hell, maybe this is already kind of cool in a way. So this already improves the game quite a bit, because we're only drawing them if they're in a certain range of the player. But the problem is we're not animating them, right? And what we're going to do today is like a little bit of hack animation. And what I mean by that is we're not going to use like Libgdx's built-in animation, which is probably what we should do. We're not going to use Libgdx's built-in animation library and stuff like that. We're just going to do it all through code, which I think is kind of cool, which is why I did it that way. We're just going to animate the textures with code only. And maybe that's not the best way to do it, but I think it's one way to do it that doesn't require you to use like any kind of animation stuff whatsoever. So maybe somebody will find that useful. I think that we're going to need to know sort of, okay, so first off, if it's not, we're going to do something else later. First off, if it's not on screen, we need to know that too, and I'll show you why in a moment. So cool, or if it's supposed to be on screen. Now, the way I did this is I made a, let's just make this private. I made an on-screen boolean here, which I just set to, let's see, on screen, false by default, I believe it was. Now, if it's supposed to be on screen, it's not on screen by default, but if it's supposed to be on screen, and it's not on screen, then we need to do something, right? We need to put it on screen. So I'm gonna say, let's see here. All right, I need to create some kind of holder variable, right? All right. We'll just call this the animation Y. And this animation Y, the reason why I need to make this will become clear in a moment. If the tile is going to start off screen, I'm going to say it's going to start 32 pixels below the map, and then it's going to rise into the map. So its start position before it comes on screen is going to be 32 pixels below the map, but it's not going to be rendered until it comes on screen. So if it's supposed to be on screen and it's not on screen, then we need to go ahead and raise it up the 32 pixels and start rendering it, right? So what we're going to do, which we're already going to start rendering it because we have this here, this is where the sort of time variable is going to come in. So we're going to go ahead and make okay, this is just like I was talking about. Now this time variable is getting the result of delta every frame. Now, this is the speed I found that worked for me. When time, so this is basically saying when 0.02 seconds has passed, go ahead and move it a little bit. I know that seems fast, but it's really not, as you'll see. So cool. Right, okay, we set this. The reason why we need this any variable is because we don't want to mess with the world position. So we don't want to be like increasing and decreasing the world position. We want to do that with like a hold variable. I like the world position to be pure and unmessed with, so that way I have some objective reference as to what the original world position created by the tile map was supposed to be. I don't like messing with it. I don't like the idea of messing with this, so I like the idea of having like a variable that we do mess with, and then just leaving world pause alone in case we ever need to get an objective reference to what the tile map originally had given this class, and there's no doubt about that that's what it had originally given it, right? Cool. Anyways, so that's why I like that. Now, so every 0.2 seconds, we need a speed variable for this, right? You know what though? I'm not going to make a variable. We'll do that in a minute. I'm just gonna go ahead and use some magic numbers here and just place something in there. So we're gonna say 4. 4 seems fast enough. Now, I suggest you make this some kind of like multiple of 32 or whatever, so that way as it adds, it eventually gets to the world pause exactly. Now there are ways around that. I just don't feel like talking them right now. And then set the time back to 0. so that it can start adding up again to the next time that it gets above 0.02 seconds. Now, what happens when they do equal each other, right? So, okay, if it's supposed to be on screen, but it's not on screen because it's not by default, then every 0.2 seconds, we want to raise it up a little. We want to start rendering it, and every 0.2 seconds, we want to start raising it up a little bit. And then, when finally it's in the correct position, we want to say that it is on screen. So go ahead and stop animating it up, because it's in the correct position, it's on screen now, so all we need to do is draw it. We no longer need to do any of this delta stuff, we just need to draw it. And in fact, so hilariously, if we don't change this, I'll show you nothing's going to happen. So nothing happened, and the reason why is because we're just drawing it at the world position. We need to actually draw it at that position. Now, if we go in, you can see the world raised to the player, and look at this. They come into view, right? Very simple, but they don't go out of view correctly, right? They animate into view, but once they've animated into view, then they start messing up. So anyways, that's because all we've done is the animate up portion of it. We haven't done the animate down portion of it. Cool. So I hope everyone understands this so far. This is very simple, I think. If it's supposed to be on screen and it's not on screen, every 0.2 seconds, as dictated by the delta variable, which will be like, which the great thing about the delta variable is that this will be on the same on every machine. Whether your computer is very fast or very slow, your computer will determine the value of this delta variable so that the time will always be correct. So it'll do it the same speed on the fast or a slow machine. And sorry if I'm being a little verbose here. I just like to explain things a little bit in detail. Cool. So now, if it's not supposed to be on screen, then it needs to not be drawn, right? But if it's not supposed to be on screen and it is on screen, then it's got to animate down, right? It's got to go back to the down position. It can't just not be drawn. It's also got to go back to the down position, or else we get those dumb little bugs that we saw a minute ago. Now, this is like almost going to be the exact same code, right? Because we have to animate it down, and we have to animate it down in the same way. So actually, let's just go ahead and copy this. The only difference is, boom, we're animating down, right? The position of the texture. So this is all like a trick, right? It's like we're just moving the position of the texture, and then we're either rendering it, drawing it to the screen with the striped edge, or we're not drawing it to the screen. It's all an illusion. This is what games are all about. They're all about creating an illusion for the player. Even though the tile still exists, the player can't see it. So it's the illusion that it just went away, but it didn't actually go away. We're just not drawing the texture to the screen. So it's all about an illusion for the player. That's what games are all about. Okay, so like I said before, yep, it's going to animate down at the same speed. Yep, same speed. And we can do variable speeds too. I'll do that in a moment. At the same speed. And let's see here. Cool. We just need its original position, which is what we set this to before. If it's at its original position, this can be any arbitrary number. Just make sure whatever number it is, this will eventually equal it when you're, so if you wanted to do multiples of 5 or something, because that makes more sense to you, that's fine too. Whatever you want to do. Totally up to you. Now, once it is in position, it's just not on the screen anymore, right? And if it's not on screen, and it shouldn't be on screen, then nothing happens. It goes to this else block, and it never renders. And we're all good. And Okay. I removed all the trees and stuff from this, by the way. I figured there was no point in having the trees for this tutorial. They would just get in the way of you being able to see what was going on, really. Okay, this is cool. Look, now they animate up. Wait. Is it not animating down? Oh, I know why. Because I'm not actually drawing it while it's animating down. So, silly me, you do in fact need to draw it, not when it's off screen, but at least when it is on screen, you do need to draw it. Because if you don't have this here, then you're not actually drawing it while it's animating. It's still animating, but you're not actually drawing it. Okay, now they go down and up in chunks, right? Cool. So that's basically it, other than a couple of things. So in my original video, I had them animate at different speeds. And this is actually as simple as you're going to have to make, see, this is where we're going to have to make this can actually be an integer, I believe. Let's make it a float. This is going to be the animation speed. You're going to have to do this. See, I was hard coding it as 4, but if you want them to be variable, you're going to have to actually make a animation speed. And the way we're going to do this is we're going to make an array of possible speeds. All of these will equal 32 at some point. 16 is actually probably kind of stupid to have here because that's so incredibly fast with this current time step that I think that you player probably wouldn't even be able to see it. But you can play with this. You can determine your time step and your speeds and stuff like that. No, this is not what I want. I actually want, I'm just going to copy paste this over because it's faster. So this will give you variable speeds, and I think it's pretty obvious why. You made sort of an array of options, and then you're using Java's random class to essentially say like, okay, give me one of these random options as this tile's, animation speed, and then you just say any speed there. Okay. So you can do that if you want. And then you can see they all came into position at different speeds. Okay. This is it. This is basically how I did it. Now, I'm not saying this is perfect. This is kind of a inelegant way to do it, like I said, because I'm not actually animating. I'm kind of hack animating everything, but I think it's still kind of fun. There is one kind of bug you can possibly run into with this where the tile gets stuck sometimes, and what you kind of need to do to fix that if you run into that bug, which it's kind of hard to recreate. Sometimes it happens a lot, and sometimes it doesn't happen at all. Like, see, right now everything is rendering just fine, like every single time. But if you happen to run into that bug for whatever reason, what you need to do is have an animation down boolean, and basically, I'll just show you. Actually, I'm just going to show you. I just want full disclosure that I think this is the only bug with it. I haven't run into another one. So if it's animating down, I'm gonna explain why this bug happens in a second. And like I said, it's hard to recreate the bug because, in my experience, it happens so rarely that it's hard for me to actually recreate it. But I have seen it happen a few times. So, but the point is you would have to make sure none of this code happens until this code is finished, because basically if this becomes true before this is finished, sometimes the tile can get stuck animating down, and then it'll just be stuck in this weird position on the screen. So what you'd have to do, you have to go and say that animation down is true, so that there's no way this code can run until this code is finished, because you want it to animate all the way down before it animates up again. That's the only known bug I've seen with this. Any other ones you find, and then of course when you're done, you have to set any down to false. If y'all find any other ones, feel free to try and fix them yourself. Maybe as a little challenge. Like I said, I haven't extensively tested this in terms of like hours and hours of gameplay. But I'm pretty sure this is how I did it for that one video, and it didn't have any problems in the video. So yeah, I'm not really seeing any problems here as my player moves around the map. Anyways, I think this is good if y'all want to use this, or maybe not even use it exactly as is. Maybe this just gives you some cool ideas for how you can use the time variable, or the delta variable. And the reason why this works is because I know when people think of animations, they think of like looping through different textures, kind of like cartoons do, right? They loop through different frames of the scene until you get a smooth animation going. But the thing is the way games work is you have a game loop constantly running. So sometimes you don't need a loop. Sometimes what you need is to just figure out how much time has passed and then do something every so often, right? And in this case, you can create animations without loops and stuff like that, by just saying like, okay, every 0.2 seconds or whatever, go ahead and go to the next, move the texture or go to the next frame of the texture. And you can just create animations that way through code, which I think is pretty cool. I'm not exactly an expert on the animation topic, but it's something to think about. This delta variable is just incredibly useful. You can just do all kinds of cool stuff by locking things to a certain time step, right? Saying this will happen every 1 second, this will happen every 3 seconds, this will happen every 0.01 seconds or something like that. So it's just something to think about. I think this code is really straightforward, and I think it creates a nice effect, and it's all contained within the tile class itself, which is nice. The tile animates itself and understands how to render itself so that the tile map isn't like all bloated with each tile's code and stuff. I think that's pretty cool. Once again, it's still a little bit messy. You could break these down into functions a little bit to make this cleaner. I've also been cooking up some kind of like entity component stuff, and I think I might try making a tile game doing some like entity component architecture. I know entity component system is like a really hot topic nowadays, and everybody sort of has a different idea of exactly what it is. So I think maybe my next video is going to be trying to cook some stuff up with that. Let me know what y'all think about this. Like I said, I really think this is just some straightforward code. That's what I like about this. This is just numbers, right? Just basic numbers. There's not anything crazy you have to understand here. There's no animation library you have to go out and learn, nothing like that. It's just straight up code, right? Anytime you can do something with just straight up numbers and basic types like booleans and stuff, I just like doing that, because for me it feels like I'm just like getting in there. I don't know, it's maybe weird, but cool. This video's gone on for about 35 minutes now though. I hope you enjoyed it. As always, let me know in the comments or not. It's up to you. Really, this is just free information. If you think this is useful to you, by all means. If you don't, that's okay too. So anyways, I'll see you guys next time.